Hi there. After understanding NPV, IRR, BCR, and NK ratio, we will learn about the fifth of the discounted measures of project worth, and which is known as payback period. The NPV and BCR, they compared the benefits and the costs with the help of subtraction and division. NKR was similar to VCR because it also compared the positive discounted net benefits with the negative discounted net benefits. And IRR was equivalent to a kind of measure that gave us the return of the project in percentage terms on annual basis. But payback period is different from these measures because it considers the time dimension, that how much of the time is required to recover the capital that we have invested. So basically it's about the return of capital instead of return on capital. This is an important question in the mind of any project manager or any intervention whenever we undertake one. We are interested to know that how much of the time is required till we will be able to recover the investment that we have undertaken in it. So the cost recovery time is basically payback period. How we can do this with the help of some empirical data. We have a project which is spanning over 30 years, and we have capital costs, we have operation and maintenance costs, we have benefits, we have the difference of the two, which is the gut reaction. Whenever we have these two elements, that is the benefits and the cost, we take their difference, and then we have the discounting factor, and then we have the discounted net benefits. So multiplying these two columns, we will get all of these values. Now these are the columns that we are very much familiar with, but the last column is the addition in our analysis. It is cumulative discounted net benefit. It means that we are going to calculate the cumulative of the discounted net benefits. The first one is the same because 0 exists before it, no other value does. So when we add these two, we get this value which is the same as the value of the DNB in the first year. But in the second one, we get the cumulative discounted net benefit after summing these values, that is this value and that value, we get this value. Summing this value and this value, will get that value. So it is the standard procedure of finding the cumulative. And once we do this, we can see that these values are progressing, and this is the final year. But this is the point where there is a change, and that change is it is becoming positive afterwards. Before it was negative. So we highlight this value because it is showing us an important thing, and that is adjacent to its value, we have the 20th year. It means that till the 20th year, the cumulative discounted net benefit is still negative. It means that we haven't done the recovery of the investment. But in the 21st year, it is positive. It means that somewhere in the middle, whenever this value turns 0, the recovery would have been done. So it means the payback period lies between 20 and 21. So as per the formula, we are going to choose some values. This one is one of them, which is actually the last negative cumulative discounted net benefit, because afterwards you will see that all the values are positive. And we will also borrow this value adjacent to it, the time period, the last time period in which it was negative, that is the cumulative discounted net benefit. And the other value that we will borrow from here is the next value after this negative value in the discounted net benefit column. So this is the DNB after this final negative cumulative discounted net benefit. So these are the three values we need to find out the payback period. This is the formula of it. You can see that these values are also there, and we can also see the formula at the same time. So you can see this formula is being applied, the time period which was representing the last negative cumulative net benefit, discounted version of it, and then the absolute value of the last negative cumulative discounted net benefit, which is this one. This absolute value should be remembered because if we use this negative value, the answer will be lesser than 20, which will not make any sense. It has to be greater than 20 and lesser than 21, because here somewhere the cumulative discounted net benefit will become 0. So the payback period is lying between 20 and 21 years. So it has to be positive, otherwise it will become negative, and it will be 20, that is 20 minus some value. So it has to be 20 plus some sort of value, which is likely to be a fraction, because this is a negative value, that is after the absolute value it becomes a positive value, and in the denominator we have this value, and in this case it is a greater value in absolute sense. So we can put these values and see that how the fraction turns out. This was the negative last value of the cumulative discounted net benefits, and this is the next year's discounted net benefit, and as we saw that it's greater, so the answer of this fraction will be less than 1. 20 remains as it is. So dividing these two, we will get 0.46, and we will add it in the value of 20, and we'll get 20.46 years. So the payback period is 20.46 years. For a more understandable form of this result, we can convert it into months when necessary, because 0.46 years means some sort of half year, or some value close to 6 months. So we have converted this by multiplying it with 12, because there are 12 months in the year. So we have this answer, which is 20 years 5.5 months. Now this is the payback period of this certain project that we were dealing with. There is a small caveat in this, and that is that we cannot this negative value basically can become a problem if it occurs afterwards. By afterwards I mean that if it occurs after the usual negative net benefits. Here you can see the negative net benefits, they are occurring for the first 3 years, but afterwards you can see that there are no negative values. It can happen because, for example, in the 22nd year we have to incur an additional cost, an unexpected cost of a big magnitude. Then the result will become negative for the discounted net benefit, and that basically is going to reverse the things, because here you can see persistently there are negative signs. But if some negative net benefit arises here, for example, the value will become negative again, for example here. So the time period of the payback will have a confusing situation, because it will be expected to be between 20 and 21, but at the same time there will be negative discounted net benefit for 1 year maybe, or a few years. So it means that switch will happen again somewhere here. In this situation, payback period is basically unable to give us any certain unique value. We will be having two values, and we will be confused between having 20 and 21 as the two values. In between we will have the payback period, or if we have payback period in between these two values, for example. So this is a caveat and a limitation of payback period, and in such situations it becomes difficult to use the payback period. So this was about the payback period and how it is calculated with the help of this calculation and this project that we were referring to, spanning over 30 years. And this is about the final measure of the project work that we are going to understand in this process, and it is known as the payback period.